Example 3.1.2, we've got 12 numbers here. They do seem to be in ascending order. Yep, they are. Part A, find the mean and the standard deviation. Given that the sum of all the values is 252, that's what sigma x means, and the sum of the squares of all the values is 5468. First of all, make sure you understand fully the difference between these things. So in this example, sigma x is 17 plus 18 plus the next one, which is 18, etc., all the way to the last value. However, sigma x squared, it's the x's that are squared here. So that is the sum of 17 squared, and the next one 18 squared, and the next one 18 squared, all the way up to the last one 32 squared. That's what that notation means. So we're going to be finding the mean and the standard deviation. Here's what you're given in the formula book. Well, part of what you're given in the formula book. This is what's relevant here. The standard deviation is that. I'm going to make use of that to find the standard deviation. Now the formula book does tell you what is meant by capital SXX, but I'm just going to use the version on the right here. The sum of x squared, which we've been given, divided by n, we know n is 12, take away the square of x bar. X bar means the sample mean, so the mean of x, and that's the other thing we need to work out. So x bar, which is the mean, is what you get when you add them all together and divide by how many there are. So adding them all together, 252, dividing by how many there are, 12. And looking at the data, what are we expecting the mean to be? Well, I'd expect it to be a little bit bigger than 20. Notice there is this one value at the end, 32, that's a lot bigger than the rest. So I'd expect it to be a little bit bigger than 20. So 252 divided by 12, 21 seems a sensible answer. And the units are centimeters. So there we go, that is the mean, x bar. We're now going to use the mean to get the standard deviation. The symbol for standard deviation is this little sigma. That's a lowercase sigma. The Greek letter sigma, that's the lowercase. The capital sigma is the one we used earlier, which represents a sum. So same letter, but one is lowercase, one is capital. Lowercase sigma generally represents standard deviation. So it's copying the formula, got a big square root, and then we've got the sum of x squared, 5468, divided by n, which is 12, and then take away the square of x bar was 21, and then carefully put that into your calculator. So 5468, quite a lot of buttons to press, so keep looking at your screen, make sure you've pressed what you meant to press. That over 12, and then take away. Be careful that the calculator hasn't put this take away outside the square root. We still want it underneath the square root. And take off the square of 21, again still inside the square root. That's exactly what I want it to be, so press that. Now in statistics we tend to give things to 3 significant figures unless told to do otherwise. So you could write that down as your answer, but I'm going to write to 3 sig fig, 3.83. And the units will be the same as the units for the mean, it'll be centimeters, and that's to 3 sig fig. That's part A. We've now got the mean and we've got the standard deviation. Just a quick note on part A, you could have gone into menu and gone into statistics, gone into one variable and entered all those values into the calculator, and then the calculator would have worked out the mean and the standard deviation for you. Of course that works, but since we were given sigma x and sigma x squared, it's actually less work to do it the way I did it there. Now if you had time in the exam, that one might be a sensible thing to do. Get it in the calculator and then compare your answers. Really good to check your answers there. But ultimately this is quicker in this particular case. Okay, in part B, we are told that an outlier is an observation which lies plus or minus 2 standard deviations away from the mean. So that means a value is an outlier if greater than the mean plus 2 standard deviations or smaller than the mean take away 2 standard deviations. So let's work out those limits now. The upper limit, x bar plus 2 standard deviations. So back to the calculator. X bar was 21 plus 2 times the standard deviation. Just using the rounded 3.83 will suffice. So that's 28.66. The lower limit, it'd be better if I hadn't rounded 3.83, but that is going to do its job. That value, 28.66, doesn't really matter in this case. So x bar, take away 2 standard deviations, just using the arrow keys, change that plus into a takeaway, 13.34, and now we can look and identify, are there any outliers? So look at the lower end. 17 is the smallest number. That's not lower than 13.34. However, at the other end, and right back at the beginning of the question, I did notice this 32 looks unusually large compared with the rest of the data. 32 is bigger than 28.66, so 32, and the units there are centimeters, is the only outlier. That does not mean we get rid of it. We only get rid of values if we know they were definitely errors. That just could be an unusually large number. So don't get rid of it.